All right, guys, welcome back to another lesson, solving a system of inequalities by graphing, okay? So we're looking at now two equations, or more than two equations, that we'll discover here later on, where we want to find not just one answer, okay, that's what we did before, right? We found one answer that makes this equation true. We want a range of answers. We want more than one answer. And so this region, as you're seeing is shaded, is answers for both this guy and this guy. Okay, so that's the goal for today, is how do we find those? So we went ahead, we solved systems of linear equations using tables and graphs. Now we're going to solve a system of inequalities by graphing. And then for the last part of the lesson, determine the coordinates of the vertices of a region formed by the graph of a system of inequalities. That's a mouthful. So here's what we're doing for that part. We're graphing three inequalities, and where they all intersect makes a triangle. And we're trying to figure out where those vertices are at. Okay? Seems kind of like an odd thing to throw at the end of this, but it's actually leading up into our next lesson. So it's like a precursor. Okay? So here we go. Solving a system of inequalities, we're going to graph each inequality. We're going to shade the corrected area. We're going to identify the region that is shaded for all inequalities. This is the solution to the system. So if you want a series of steps, you can go ahead and write those down. Okay, so here's our first one. So I have y has to be greater than or equal to 2x minus 3. Y is less than negative x plus 2. Okay, I want to find answers that make this guy and this guy true. And here's the part that we got to be careful with. There's more than one answer that will make this work. So what we're going to do is we're going to graph each one individually. Okay. So let's see. This one starts at negative 3. I'm looking at this guy. And we're going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay. I'm going to stop there for right now. There's my first line. And just like the previous lesson, I'm not going to draw it yet because I'm going to see what point they both share. Now the other one starts at 2, and we're going to go down 1 over 1, okay, down 1 over 1, down 1 over 1. All right, so it looks like we have an intersection point somewhere around in this general region. Now this is a hand-drawn graph, so it's not going to be as accurate. So let me just check here. Yeah, it's going to be sort of close. It's going to be in between these 2 points there. So we'll see. It's like I said, it's going to be close. I don't think I have an exact one for this first example. I don't think I did. No. So we're gonna estimate just a little bit here. Okay. So I apologize. So for the first one, first one's down here. It's going to be a solid line. Just like that, okay? Because I'm allowed to incorporate solutions that work with it. And for this guy, it's going to be a dotted line. Okay. And the reason why it's dotted is I'm not allowed to include solutions for that. Now, if you like to color, this is your type of problem. So for the first one, it says I'm going to shade above this line. So it's all these guys here. This one says you want to shade below the line for that guy. Okay. So now take a look. When I'm looking at this, I can see that these two regions right about here are overlapping. That's where the red and purple are. Okay. So what I could say is this entire shaded area, it's an area we're looking at, are all my possible solutions. Okay, we're going to put possible there. I should put possible. All my possible solutions. That does not look like any. There we go. Okay, now how do I know if this works? Well, check your answers. Okay, so let's check. I'm going to plug in, what the heck, we'll plug in negative 1, 1. We'll make it easy. Okay? So for the first equation, I'm going to have 1 is greater than or equal to 2 times negative 1 minus 3. So does that work? Is 1 bigger than this guy? Well, that's negative 2 minus 3 is negative 5. I think that works. That's a true statement. Okay, over here, we're going to have 1 is less than negative of a negative 1 plus 2. So this and this gives me what? 1 plus 2 gives me 3. Is 1 less than 3? Yeah. So that region is going to work for all possible. This region has all possible solutions for that system. Okay. So like I said, if you like to color, there you go. If not, I mean, you can still shade it in. Some people can visually see it just by in their head. They can say this is going this way, this shading is going down here, so it has to be this set of solutions in there. Okay. Pretty cool. So I do have it. If you can't see it right there, I do apologize, but here is what it looks like a little bit blown up for you. So the yellow and blue are both going to combine here in the green region. So everything here is going to be solutions to this guy. Okay. Now, just be careful. This region is only going to work for the dotted line, which was what? Equation number 2 over there. The yellow, okay, is only going to work for the solid line, which is 2x minus 3. Okay. So individually, these are solutions for the individual equations. But together, these solutions are going to work for both of them. Okay? All right. So let's take a look at another example here. And I'm not going to graph it right here, but I want you to look at the possibilities that we have. Okay? Pause the video so you can see what the solution is going to be for this guy. Put my ruler down there. Okay? So let's see here. This one says we're going to shade what? Beneath the line, and the y-intercept at negative 3. So if I take a look at the lines that have the y-intercept at negative 3, and I want to shade beneath it. Okay? So that's everywhere beneath here, 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 and here. This one says we have a y-intercept of 1, it's dotted, which they all are dotted, and they're going to shade all above the line for everything here. Okay? So I think there's only one possible thing that works for it. And I think it's going to be B, right? So if you look at this, the solid line, you're going to shade below it. The dotted line, you're going to shade above it. So this little corner piece is going to be my solution for that guy. So B would be the correct answer for this. Okay? Same procedure. I'm going to take my system, I'm going to graph it first, shade the regions, see where they overlap. Okay? Let's do one more together before we jump into something a little different. So y greater than or equal to negative 3/4 x plus 1. Y is less than or equal to negative 3/4 x minus 2. And I gotta erase this. It's the only bad part about hand-drawn graphs. It's hard to keep it for multiple problems. But we're gonna try my best. Actually, I'm not doing too bad of a job. I think I'm doing pretty good trying to keep this. Okay. It might not be perfect, but I still think this is pretty good. Okay. So first step, graph each line, keeping in mind the dotted and solid lines. So the first one starts at 1, okay? And we're going to go down 3 over 4. So down 3 over 1, 2, 3, 4. There's my next point. It's going to be a solid line. Now, notice something. I kind of changed what I did here. See how I'm drawing the lines automatically? Usually I say wait and see where the points intersect at so you get a better accuracy. I'm not this time. Think about why. This guy, I'm going to start at -2, so right here. And I'm going to go down 3, 1, 2, 3. And I'm going to go over 4, 1, 2, 3, 4. This guy is also a solid line. Now my graph is not as accurate, but the reason why I didn't plot more points, both of these lines have the same slope. So I'm already thinking in my head, oh, these guys are parallel. So they're never going to intersect. Now mine kind of looks like it's going to down here. I apologize. It's hard to mimic this, like I said, by hand. Now look at the shading part. Okay? The first one says I'm going to shade above the line. So that's all this. Okay? The other one says I'm going to shade below the line. I want less than. So let me ask you this. What kind of solutions are going to work for both of these guys? Answer is there isn't. There are no solutions to this system. Now let me clarify something. There are solutions to each individual equation. That's what the shaded regions here are showing me. But together, there's not a region or any sort of XY pairings that will make both of those guys true. Okay? So there's a no solution problem. Alrighty? So when you have parallel lines, you could encounter that. Okay. So let's talk about a different type of inequality here. Okay? So read that while I'm erasing stuff. Did you read it? You didn't read it? Come on. Gotta read fast enough than that, right? Okay, medical professionals recommend that patients have a cholesterol level below 200 milligrams per deciliter of blood and a triglyceride level below 150 milligrams per deciliter of blood. Write and graph a system of inequalities that represents the range of cholesterol levels and triglyceride levels for patients. Okay. Now they do give us some information here that we're going to use, and they notice that they also give me some variables I can use, C and T. That's nice. So cholesterol, okay, has to have what? Below 200, so less than 200, okay? But it has to be bigger than 0. It could be 0. You could have a 0 cholesterol level, okay? And actually, I have it written down here for us. Now, triglycerides, we use T, okay, has to be what? Below 150? So it's kind of the same range. It has to be above 0, or it could be 0, but it has to be 150. Okay? So here are my inequalities based off of what they give me. Now, let's see if I can draw just a small little graph here. Okay. And since we're in 200, 150, I'm going to count by, what do you think, 25? 25, 50, 75, 100, 25, 50, 75, 200. 25, 50, 75, 100, 200. Okay. So I'm going to make this guy my cholesterol levels. I'll make this guy my triglyceride levels. Okay. 25, 50, oops. There we go. Just like a good graph, I should label everything. Okay? Alrighty. Now, what is this going to look like? Well, let me ask you this. When you had graphs that gave you what? X is 2 and Y was -1. We were talking about horizontal or vertical lines, right? Very similar to this guy here. So if I have this being C equals 200. Okay, my cholesterol is on the x-axis. So if it's 200, then that means I'm going to draw a nice vertical line right here at 200. Okay? That's telling me that I can't go any further in this direction, right? It's like a stopper. So now look at T. Okay, T, you can't go past what, 150? Boom. Okay? So you can't go past that level for your triglycerides. Okay? But that's within the recommended level. I mean, you could go past it, but it's not good. Alrighty? So far, so good? So where these guys intersect at, it's easy to tell. It'd be 200 and 150. Okay? So that's like your max recommendation levels, right? Your max level. Max recommendation levels. Okay, now the shading part. So I want all my cholesterol levels to be below this guy. So that's shading in this direction. I want my triglycerides to be below 150. So it looks like all my solutions are right into here. Okay? So if I pick this point right here, okay, that point is 50, 75. Is that within the recommended levels? Yeah, absolutely. Okay? So visually, this is a cool way of figuring out like all the different types of, all the different combinations you can have when it comes to cholesterol and triglyceride levels. Okay, for patients, be a good visual to show people, right? If you show people inequalities, depending on what type of person they are, it might not register. A visual is always a nice thing. Okay, so not too bad. And you can see right here, that's like the sweet spot. Okay, you don't want to go past that point, that intersection point. Okay, so far so good. All right. So what we're going to do now is we're going to do this last section. Okay. So let me just change gears. And here's where I'm going to have some fun graphing. Now, my graph is not going to be as accurate, but you guys have graph paper available to you, so your graph is going to be a lot better than mine. Okay. This. Okay. So we have a lot going on in this problem, don't we? We have this inequality. We have this inequality. And we have this guy. We got three inequalities here. And it says, find the coordinates of the vertices of this figure that's formed by it. Well, we're talking about three lines. So when three lines intersect, they're going to give me a triangle. Okay, so I'm looking for a triangle here. Okay. Well, if I'm going to graph this, the easiest way to graph it is make each one of these what? That slope-intercept form. Okay. So for this guy, I'm going to take 2x over to the other side, divide by a negative. So y is now less than or equal to, because it changes that, right? It'll be 2x plus 1. Okay. This guy, I'm going to subtract x over. I get y is less than or equal to negative x plus 4. And then I'm going to subtract x over, divide everything by 4. So y is greater than or equal to 1/4 x plus 1. Okay? So that's my first step. Make it easier to graph. Put it in the right format. Okay? I think I just gave myself a splinter. Man, that hurt. All right. So I want to make sure that my points are roughly where they need to be. Okay. So what I'm going to do is we're going to start plotting the first one. So we start at 1, and the slope is going to be up 2 over 1. Okay. I'll plot 1 down here. So down 2 over 1. Okay, so here's my first line. Like I said, typically I would wait to draw your lines, draw your points first, but since this is a hand-drawn graph, it's not going to look So it's going to be a solid line, okay, because I'm allowed to include those solutions. Shading, I'll get to a little later. Okay, next one. I'm going to start at 4. 1, 2, 3, 4. And down 1 over 1. So it looks like they might intersect here. So down 1 over 1. We'll do one more. And then we'll go in the other direction. Up 1 over 1. And like I said, my graph, not good. Like I said, you have the graph paper, yours is going to be a little more accurate. And the last one, we're going to start here at 1. We're going to go up 1 over 4. 1, 2, 3, 4. So right there. So here's my next line. I'm only going to use 2 points for that one because the goal is to create a triangle, and I did. It's right here. Okay? Now shading, where are we going to shade this at? I know the problem doesn't ask that, but it's important. And you could probably guess that the shading is going to be this triangle. So for the first line right here, it's 2x plus 1, right? So it's this line, and we're going to shade less than that. So it's in this direction, okay? This line, which is right here, says shading in this direction. And our final line says the shade above it. So it is going to be this little triangular piece. That's pretty cool. This little piece is going to satisfy all the solutions for all 3 of these guys. Now, the points, and like I said, I'm going to tell you what these points are so it's a little more accurate. It would be 1, 3. Okay. The next one would be 4, 0. Uh-oh. I think I might have graphed something wrong. And the other guy is going to be 0, 1. Did I graph something wrong? Oh, I did. Do you see my error? Do you see it? You might have been screaming to me about it this whole time. That should be negative, right? Oh, no. So then, let me change this guy. That's all right. It's a minor change. We can do this. So we're going to start here at 1, down 1 over 4. It's okay. We can make the change. No big deal. There we go. So we'll just shade this guy right there. Okay. So all 3 of these points are technically, we call them critical points. And we'll talk about what their purpose is in a future lesson. But for right now, you just need to know how to graph these, where they intersect at, and where the shaded region is going to be, which will be this nice little triangular piece. Okay? All right, guys, that's it. I try to keep the lesson video at least with a good size. I'm going to upload my teacher notes. There were some examples I skipped. Feel free to look through those. It's just more of, I have another example of this, and I also have another word problem example too. So you can use those to work out some extra practice if you need it. But other than that, that's it. All right. So hey, hope you're doing well. Next lesson, we're going to be talking a lot about optimization. Okay, which is a very fun lesson. So hope you're having a good day. If you have any questions, please let me know. But until next time, guys, take care.